Hi all, welcome back to my channel PySpark Pulse. So in this lecture we'll be learning about the PySpark transformation, and in the next lecture we'll be doing the hands-on on this PySpark transformation. Okay, so let us continue with this lecture. So first of all, what are Spark transformation? So Spark transformations are basically the function that are applied on resilient distributed data set, that is RDD, or a data frame, to create a new RDD or a data frame. So you can consider like whenever a transformation is applied to a data frame or an RDD, every time it will create a new data frame and or a new RDD. The resultant will be a newer one. Okay. Also, we can see the transformation are the building blocks of Spark computation and that are used to define a sequence of operation that transform the data. Obviously, like whenever we write in Spark script, right? So there will be a lot of transformation involved. So that will be helping us to, clean the data and gain insight from the raw data. So transformation are very necessary things. Okay. So let us look on few characteristics of transformation. First is immutability. Transformation create a new RDD or data frame rather than modifying the existing one. So RDD data frames are immutable data structure. So this is like the property of the Spark, right? Immutability. So whenever transformation is applied on an RDD or a data frame, it will result into a newer one. So first character is immutability. Second is lazy evaluation. Transformations are lazy evaluated, which means they are not executed until an action is triggered. This allows Spark to optimize the execution plan. So yeah, lazy evolution is also one of the characteristics, and like whenever an action command is triggered, then only the above transformation between the two action command those get evaluated. Until and unless the action is triggered, the transformations are not evaluated. Okay. So there are two types of transformation: narrow and wide dependency transformation. For narrow transformation, we can say that each partition of resulting RDD depends on only one partition of the parent RDD. Okay. Some examples include map, filter, or union. For wide transformation, there is shuffling between the data partition. The data is shuffled between the partitions. Okay. And then a dependency graph. Spark maintains a directed acyclic graph tag that we have discussed in the earlier video. What is tag? And I have told like I will be explaining in the upcoming video. So in the next video, while I will be explaining about a transformation with the example, then we'll be looking on the DAG and visualize and like let we will see how the stage and how the job is created in the Spark. Okay, so I have created this narrow versus wide transformation in a tabular form, and we will go through each of this feature one by one. So definition, we consider operation where each partition of the resulting RDD depends only on one partition. In narrow transformation, like only one partition is involved. Wide transformation, as the name suggests, the data is like wide and like the data is shuffled between the partition. Dependency, each partition depend only on a single partition of a parent RDD. Each partition may depend on multiple partition of the parent RDD, because the data can reside, in multiple partition. That's why like it has dependency in other partition as well. Data movement, no data movement or shuffling is required. May involve data movement or shuffling between the partition. Okay. Example, select, filter, union, group by, reduce by key. Efficiency, typically more efficient as they involve less data movement. Obviously, if the data movement is less, so less input output, less IO will be included. Okay, so less CPU will be utilized and therefore it is more efficient. So here in the Y transformation, it involves overhead due to shuffling of data between partition. Optimization, narrow transformation provide more optimization opportunities. Y transformation have limited optimization opportunities. Generally, simpler execution plans be more complex due to shuffling. We will see the DAG of narrow and wide transformation, and you will find that the DAG of wide transformation is more complex. Okay, you can pause the video and go through it. This might be asked in interview as well. What are narrow and wide transformation? What are difference between them? Okay, so this is the image explaining wide transformation and narrow transformation. So input and output stays in the same partition. Consider like these are three partitions of a single data. Okay, and there are some, suppose we are doing a narrow transformation. Let us consider like select. Okay, so we are doing select like wherever the id is greater than wherever we can select a salary. Let's consider salary wherever the salary is greater than 500. Okay, we can uh, use that. We have to select that data. Okay, let us look. Let us okay, let us insert one thing. Whenever cell is greater than distribution, 500. Okay, 5,000. We wanted that data. Okay, so in case of narrow transformation, what it will do, it will check here a salary for the first column is suppose like 100. Okay, 1000, 2000, 8000, 9000. So in C and D, it will find 9000. So it will like select those two columns. Okay, those two rows. And similarly here in B and C, it is 9000, 10,000. It will select those, and such that it will, you know, select all the rows which uh, qualifies this filter statement, and we'll getting the partition according to our requirement. Okay, now consider a wide transformation. Input from join partition are required. Address shuffling is needed before processing. So suppose there are data in the executors of the worker node. Okay, so for this data, suppose we are doing group by transformation, and we have done group by on, certain characteristics. Suppose we have done group by on male. Okay, suppose you have done group by in male, gender male. So some gender male, suppose 1 2, this is there. Okay, and here this for these two data male is there. Okay, and for here this two male is there. Okay, so obviously all the male things, suppose male and female will be going into the one partition, right? All the males will be going into one partition, all the females will be going into one partition. Okay, so like that, if the transit is the if this if this executor is full, then again this executor will utilize all the males will be going to one partition. So like this, if we do group y, then such scenario is like y transformation, because obviously data needs to be shuffled. All the males need to be in one partition to get the accurate result. Okay, that's why this y transformation required shuffling and are expensive in, processing. Okay, so now let's go to the example of narrow transformation. Some examples we can see, like select is a narrow transformation, selecting some of the columns. Then filter is a, this we discussed, filter column 3 greater than 100, like simple similar example we discussed. So this is also narrow transformation with column. Okay, this is also narrow transformation. You have to drop, you want to drop a column or renaming a column, all this falls under the category of narrow transformation. Let's discuss some example of wide transformation. Group by we have discussed. Okay, then joining is a wide transformation, because obviously we need to join two data frames, so data shuffling is required on the bits of primary key. And again, sort is like all the data need to be sorted, so that also requires shuffling. Okay, so I think that's all for this video, and the next video will be discussing on the hands-on, and we'll visualizing the DAG, because that video will become more bigger if we like, go through each of the transformation and visualize the DAG. So that will require a lot of times, and so obviously this will video become longer, so I don't want that. So yeah, do subscribe my channel and let me know if you have any doubts regarding narrow and wide transformation. These are very important for interview as well. So yeah, please comment your views and do support, subscribe my channel, and yeah, wait for the upcoming videos. Thank you.